Hello and welcome to Unit 1, Algebra. This is Mrs. Hayes, and I'm going to do notes 1.1. So we're looking at the cover page of our packet. We're going to cover rational and irrational numbers today. So you're going to start on the next page, which is notes, and make sure you're on 1.1. This page is primarily filled in for you already if you look. So I'm going to go through a few highlighted things with you. If you have a highlighter, that would be great. If not, you should be underlining as I go. So review means you should already know this. And we have whole numbers, integers, and sum and product are the four key words here. Whole numbers are 0, 1, 2, 3, 4, 5, and so on. Notice that there are no decimals. So if you want to make a note of something, you could say no decimals. Those are whole numbers. Integers, if you look, also are basically whole numbers, but they have the positive and negatives. So when I think of integers, I think positive and negative whole numbers. The other words to think about that we need for today are sum and product. Sum and product. Sum means add, so it's the result that you get when you add two numbers together. Product means multiply, the result that you get when you multiply two numbers together. So add or multiply. Sum, add, product, multiply. So today we're going to find out the difference between irrational and rational numbers. So rational numbers have a couple different ways of defining them. I wrote two definitions here. A rational number is any number that can be written as a fraction of two integers. So if it can be written as a fraction, it's rational. Opposite of that is irrational numbers can't be written as a fraction. Makes sense because of the ir part means not. Definition number 2, a rational number is a decimal. So if it's written as a decimal, it ends or repeats a pattern. The opposite of that is irrational number. If it's written as a decimal, it does not end and does not repeat. So just a quick little example, my favorite rational number is 1/2 because it can be written as a fraction. As a decimal, it's 0.5 because it ends, it is still a rational number. If it starts off as a fraction, you know right away it's rational, but you can tell it ends, still rational. Or 2/3 is a fraction, but when it turns into a decimal, it's 0.66666, and it repeats a pattern. Those are good examples to remember for rational numbers. They end, they repeat, and they can be written as a fraction. If it's irrational, it's going to look like when you hit the square root of 2 on your calculator. So on your calculator, if you were to type in the square root of 2, and you look at what you get a decimal that does not repeat any pattern, and it just goes on forever without a pattern. So let me go back to that. That was 1.4142 dot dot dot. 1.4142 dot 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 dot. It goes on forever without a pattern. So here's a couple of ways that the Regents asked questions with explaining, and you have to show some words. I gave two possible answers. Is 7/6 rational or irrational? Well, I think it's rational because it's a fraction of two integers. You could also say, I change it to a decimal, and I got this thing, which is a repeating decimal. Therefore, it's rational. Rationals are fractions. Rationals repeat. Square root of 10, is it rational or irrational? Explain. Here's one answer. It's irrational because it can't be written as a fraction of two integers. Or, I change it to a decimal, and it doesn't end, and it doesn't repeat a pattern. Remember, underline things as I'm going through these notes, and it will make more sense to you in the future. These are screenshots of my calculator over here, so you can see what you get if you type them in. Is the sum, okay, sum, that means add, so I'm adding radical 16, square root of 16, with 1/7. Explain, is it rational? Explain. Well, I think it's rational because it can be written as a fraction. On my calculator, I got 29 over 7. That's a fraction. If you turned it into a decimal by doing Control Enter, will turn it into a decimal. Or when you typed in the 1/7, if you put a decimal point after the 7, you're going to see a decimal that repeats a pattern. This one's tough because it goes 142857, 1428, and then it got rounded at the end. But it is repeating the 142857 pattern. So it's rational. Rationals repeat, or rationals look like fractions. All right, let's do a few more examples here. Product. Is the product rational or irrational? So we first have to answer that, pick a choice, and then we have to explain. So I went to my calculator and I typed these in. Let me see if I can find them. 5 rad 2 and 3 rad 8. And when I did it, I got 60. I multiply them together, I got 60. So I'm going to say that the answer is rational because 60 is 60 over 1, or 60.0. It's a fraction, or a decimal that ends. You don't have to say all that. You could just say it's rational because it can be written as a fraction. Next example, I want to know, is it rational or irrational? And I want to explain my reasoning. Sum means add. So I'm going to go to my calculator with these numbers. I believe, wait a minute, negative 2/3 and radical 5 over 2. Yep, that's the answer. And if you look very carefully, I don't see anything repeating. So I'm going to say irrational because the result, that's what I got when I multiplied, is a decimal that doesn't end, and you gotta have both parts, it doesn't repeat a pattern. Number 3, for what values of P and W is P plus W a rational number? So first think, I would like to see a fractional answer. It's going to be something that looks, I would say, nice. So if it comes out as a decimal, it's going to end or it's going to repeat. So I'm going to take these things to my calculator with a plus in between them, plus, 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 just the numbers, take them to my calculator and see what I get. I'm looking for a fraction or a nice number that ends or repeats a pattern. So I did that somewhere. There they are. So this first one was not nice. The second one was a fraction. So there's my answer. I kept going and checked all my choices just to make sure. So when I typed them in, I found the answer to be choice 2. And I justified because I showed what I got on my calculator. When I add those together, I get 5/6, which is a fraction. To be better at justifying, you could give all of these decimals and show what they look like. All of these came out to be ugly decimals and show what they look like. This next question is really tricky, and we might want to discuss it in our classes, but just to give you the idea of what's happening here, it wants you to know which one is not always true. So in order to justify it, you'd have to come up with some examples and show why this is not always true. So I'm going to start with choice 4 just because I have more space below it. The sum of a rational number, so I'm thinking maybe 0.5, and an irrational number. So I'm going to add it, because it said sum, to something like 1.4639, ... some ugly decimal number that keeps going. So rational and irrational. When I get those added together, basically it's going to be 1.9, but I'm still going to have the 639 ... So I can tell that it will always end up irrational. So anytime you take an irrational number and you add it to something, you're going to still have an irrational number. That's always going to be true. It's not the answer. I'm looking for the one that's not always true. The one that's not always true is choice 1. And like I said, we can discuss this more in our class. But when you multiply, some weird things can happen. If you take two irrational numbers, like the square root of 2 and the square root of 8, it can create a rational number. So it's not always going to be irrational. Because if you suddenly create a perfect square, it can come out nice. Now, I could pick another example, and it would stay irrational. If you look at your calculator on that. But this happened to create this perfect square, and it came out rational. So that's the one that's not always true. Thank you for joining me, and make sure tomorrow in class that you know how to use your calculator to type things in, like what we saw in question 3, those 1 over radical 3's. Make sure you get experience with your graphing calculator, and you know the definition of rational and irrational numbers.